Hi, hello everyone. In this video, this is my first attempt to demonstrate Universa AI. And what I do in this video is just record my workflow, how in this particular example, how I'm working on smart contract development using Universa AI in the process and how it helps me to transform my experience as developer. So this is the first video on this topic, and in the next topic, I'll demonstrate it for different use cases and we'll go more in details and go less technical. But in this video is just spontaneous example of how it works in this particular case for development. So Universe AI, um, I run it here in my terminal in this case. So uh, it begins with this file that I open, and this file is actually a prompt. So every prompt in a Universe AI is always a separate file. So that's the core concept to understand is the structure of the prompt. It consists of those different messages from different roles. So in this case, we can see here, how can I show that you can see at the beginning of this file uh, as a system message, right? And the system message inside of it, it can point to particular agent that you want to use in this case. So here I have, for example, um, system prompt for agent that will develop unit test for my smart contract. So this system message is also a separate file. And where it gets really flexible is mm, because we have this composability that I can include different fragments of prompt inside of my main prompt. So this is, you can see it's called agents solidity hard hat. So it's a separate file. It's a fragment that I will include inside of my system message. So I go back into my main prompt, and here you can see dollar sign cut, and then it's path to this prompt for my agent. So every line that begins with dollar sign, it's actually being executed with bash script. So I can use any bash commands. In this particular case, I use this cat command to take the content of my agent prompt and just include it inside of my main prompt. So the same I do to include content of different files, including my smart contract source code. Inside of this file, I use just cat, and I can use environment variables inside to point to the actual current version of any file on my file system. And then I put separate message, as you can see, user separator in here, and there it means it begins a new message, just like that. In this message, I describe the issue that I want uh, to, to fix, and I wish I can have laser here to show it. So anyway, I just write my message. So in this case, I want to fix this particular file. And then what happens? It happened too fast, but what I write in my process, I just press semicolon WQ or just in my case, when I'm using Helix instead of Vim, I have a configuration that whenever I just press escape, it will automatically save file. But here in this case, I just press semicolon W, and so I just save this file. And whenever I save any file inside of my prompts directory, what happens that Universa AI will pick up those changes, and that's what happened in here. It say detected change in this prompt, re-executing prompt. So what happens? It takes this prompt, it transforms it, resolves all bash commands inside, it executes this prompt to my LLM, and then what it will do is a response. So in meantime, I can make changes to prepare my next prompt. So I can see in background that the previous prompt has been executed, and now I'll switch back into here just to check to show you what really happened here. So when it has executed my prompt and got a response, what it does, it always creates a new branch, or for so using Git repository, it will check out to the branch that includes the name of the file that has been changed. So it does not touch my current working tree, but it just makes those changes into a separate branch. So it write a separate branch, so you can see it does stash and pop if necessary. So then now I go to my Git client, lazy Git here. So in lazy Git, I'll go to this new branch. It called, in this case, temp.sol. Temp.sol, you will see why it's called temp.sol later and how you can use actually to transform particular sections of other files, specific sections. But here I just use simplest case, just new file, temp.sol, and I go here. So in lazy Git, I press C to check out it from that branch to my current working tree. And I go into here, and this is was the response. I just take it and put it into. So I review it. I put it. So you saw that I removed those unnecessary segments, prefix and suffix. I'll later show how to do it automatically. So I take it and I replace it into my actual file. I do override it, and now back into my Git client, I can see this difference. So I can see uh, this actual Git diff that I can compare to from my changes, and then it's especially useful, this model, as you will see, when I can run several prompts with different temperature, as you can see here. So here, for every change, it writes what file it has been changed and what temperature it used in the prompt. It's a great benefit over similar AI editors like Cursor, which just outputs something for you, but you don't have direct control over the prompt, over the temperature, and it's very powerful where you can execute the same prompt but with different temperature, and then using gdiff you compare which result is the most relevant to you in this case. So I just continue my workflow working on this. Now I use different agent to write now unit test for that conflict. And now when we go back to prompt, something else that I want to show, it's that, other than the messages in our prompt of Markdown here, if we scroll back up, before we saw that we also have front matter. So in front matter, before the actual prompt, we can specify our different fields such as target. It is the file that will be receiving the result of execution of our prompt. And we also have special fields such as special markers to specify which part of the file we want to override and also which part of the response from AI we want to extract before overriding. So this way it's very flexible and helps me to build using this workflow in not just efficient but also very satisfying way that I can have full control over execution of my prompts, compare different variations, and because it's based on Git, so you can see what happens next. So it's important piece of it. It's actual execution of this code. So I write this contract and test, and now I want it to be executed. So I actually make, so before it was committed, I had commits to different branches that AI made for me. So now when I'm ready to execute this code, now I actually select the actual files that I review, and now I will make a new commit. So you will see it, I will manually write like this commit message, and I make commit, and I commit this to my development branch. And I don't want to execute this code into my local machine. Instead, what will happen as part of the system, a remote machine, in this case, it's another computer that I have straight to my development machine. It will run this code and it will execute it. And as you can see, we will see here the result of the execution. You can see right here, 5 seconds ago, in this branch BGR, this is the result of the execution of this code. And you can see it has the logs of the execution that signifies that there is an error in this code. And so this actual result, it's actually written always in this special folder with in file with special name, so that I can actually reference this result of execution inside of my prompt now. So I have this continuous loop, so I reference this output that includes the error message inside of my new prompt, and my new prompt updates the code. It executes again on the remote machine. It updates the same branch inside of my repository with a new output, and so they have this communication based on those events, using those listening to the changes in this repository. And this is very powerful, very efficient workflow that I just want to demonstrate now. And you can already imagine how it sets a foundation for different use cases of communication between many agents, and different even people in the loop, how you can build your on top of a different interface for not technical people to fulfill different cases of applications with AI in the core of it and with yeah, human in the loop. So this is very powerful. That's what I want to show now. Thank you for your attention.